Hello and good day everyone, and to our beloved lecturer Dr. Noor Izzatun. Meet myself, I'm Dina, metric number MA19218. Today we are here to do a presentation regarding on the experiment Thermolab 1, which is known as the air conditioning refrigerant system. As a team leader of Group 1, I would like to explain some details regarding on this topic and followed by another of my team members. So let us see. To start with the introduction section, what is really air conditioning is? Air conditioning is a common of aspect of building engineering. This was designed to provide occupants with a sense of comfort and security. So we can say that this air conditioning system primary functions are used to provide heating, cooling as well, humidifying and dehumidifying factors. And we can say that in order to provide the appropriate indoor air conditioning, the air conditioning includes all components of building central air conditioning system. Also, this system includes a complete refrigeration unit, which enables to conduct the majority of experiments. In this experiment, we are about to focus on theoretical introduction to the individual components and their mode of functioning, and later on the principle will be discovered in more detail in this experiment. We can say that this does not involve a lot of calculation. This was due to the measured uh, details which were found on the digital indicators of the equipment, which were used for recording and calculation purposes. Okay, now let us move on to the general description. As we can see here, it shows a figure regarding on the equipment that we use, which is known as the unit construction for the air conditioning unit, model AC01. So based on the model, we can say that this type of air conditioning unit principally consists of two assemblies, which is the air conditioning system and together with the refrigeration unit. So let us move on to the next part. Okay, in this section, we're about to see the types of assemblies or the unit that we use to conduct this experiment. So the first type of the unit is the air conditioning system, as you can see here, together with the schematic diagram for the air conditioning system. So to review the parts, the components of the air conditioning system, the first component is the combined temperature, which is known as the relative humidity transmitter. It can be said as a measuring probe which consists of a temperature sensor and relative humidity sensor. So the next part is the radial fan. The radial fan can be said it acts as an air volume flow which can be varied with the aid of speed adjuster. So the next part is the steam humidifier. Uh, it has an electric power consumption of 2 kilowatt. The next part is the preheater. In preheater, we can say that this unit consists of 4 electric air heaters with an output of 0.5 kilowatts. So the individual heaters can be configured to enable heating powers of 0.1 and to 2 kilowatt to be set. So the next part is the evaporator. In this unit, the evaporator is used to direct evaporator of a refrigeration unit. Okay, the next part is the reheater. In this unit, the reheater is constructed in a way exact the same way as the preheater. So in the last component is the orifice. So we can say that the mass flow rate can be calculated from the orifice correlation by measuring the differential pressure across the orifice. Okay, now let us move on to the second assembly in this unit, which is known as the refrigeration unit. As you can see here, it shows the process schematic diagram for the refrigeration unit. So based on the figure, we can propose that it has 4 types of components, which is known as the compressor, condenser, expansion valve, and together with the evaporator. So we can say that the temperature and the pressure in the refrigerant circuit can be measured by using the electronic sensors and the indicated on the digital indicators. So the volume flow of the refrigerant is measured with the aid of the flow of the transmitter. So based on the previous section, we have talked about the refrigeration unit. So in this refrigeration unit, it involves in four basic processes in a vapor compression refrigeration cycle. So based on this schematic diagram, we can see that there are five components of it. The first component involves the compressor, which involves the refrigerant to experience compression process, and later on the refrigerant will move on to the condenser, which allows the refrigerant to experience condensing process, and later on the refrigerant will move through the flow transmitter and later on to the expansion valve. In the expansion valve, the refrigerant will experience an expansion process. In the last section, the refrigerant will move to the evaporator section and later on will experience the vaporizing process. So I think that's all from me. I will continue the presentation to one of my member, Mohamad Eizzat. Thank you.
Hi, my name Muhammad Eizzat bin ZAHEERRUDDIN, matrix number MAY9259. I will present about 3.0 experimental procedure. It is a general startup procedure where we need to perform a quick inspection in hopes that proper operating condition. Then make sure these two units are connected, which are the humidifier water supply and tap water source. The third is to connect a drain hose to the condensate collector. Turn on the power supply and the main power. These are the procedure where first switch on the radial fan and run it with 50% air velocity. Second, switch on the refrigeration unit. Third, allow the system about 15 minutes to reach a steady state. Lastly, record all type of unit needed. 3.2 is a general shutdown procedure that has 5 easy steps. The first is to switch off the heater and cool down with the fan. Then turn off the fan switch. Third, make sure the switches on the control panel are switched off. Next, switch off the main switch and power supply. Lastly, close the tap water supply. Then, 4.0 is a result of the refrigeration system. From this table, there is 7 types of result that has been recorded, such as point temperature, point pressure, flow rate, enthalpy point, specific volume, mass flow rate, and output value. All these types has different meaning and different value. After that, I will talk about 4.1 compressor performance or output. As we can see from this table is a result of value from the calculation for a different type of output. First is actual compressor work where the value is 6.99 kilojoule per kg. The second is the actual coefficient of performance is 24.98. There are many other types of output such as theoretical compressor work and theoretical coefficient of performance and many more. All types of output has their own value.
Assalamualaikum, my name is FATIHAH binti AZHAR, my metric number MA19253. Okay, I will continue into discussion. Okay, for the question number 1, briefly explain how condenser, compressor, expansion valve, and evaporator works. Okay, first, condenser. For taking latent heat of fluid and converting it into liquid form. Coolant will flow from the tube and steam will be enters from the outside and contact the cooling tube. The steam will be converted into the liquid form to absorb heat and condenser will liquid form. Okay, for the compressor, it's work by pump air into the freezing container. The air is then divided through an inlet in the tank, where it's brought up pressure condenser and open balloon. As the compressor air is released, it can generate electric. They are propelled forward by a motor that converts electric energy to the kinetic energy. Okay, for the expansion valve, will condense liquid refrigerant enter the system after it passes through the evaporator and into the fluid line. The temperature of the refrigerant will drop a point below it at most when the pressure on the refrigerant is reduced. The evaporator will then be filled with this liquid. Okay, next, evaporator. A device that converts any liquid into gas, heat taking place throughout this process. A low pressure evaporator boils a liquid refrigerant which transports heat from the chilled compartment to the heat pump. The liquid refrigerant should be lower than the product being cooled to transfer the heat. With a suction line, the compressor removes the liquid refrigerant from the evaporator once transferred after exit the evaporator coil, and the liquid refrigerant will be in the form of vapor. Okay, for the question number 2, based on your experiment, sketch the basic refrigerant cycle and plot the point on a pH diagram to obtain a complete cycle of the process. Okay, here we can see Q in, heat in into the evaporator. Here we can see the low pressure vapor. After that, it go to compressor. From the compressor, we'll go to condenser with the high pressure vapor. Then go to expansion valve. Here we can see the high pressure liquid. From the expansion valve, the low pressure liquid vapor will go again to the evaporator. Okay, this one is the cycle process. And here we can see the pH diagram, the pressure and the enthalpy. Okay, that's all. Thank you.
Greetings and Assalamu alaikum. My name is Irsyad and I will present the topic for discussion of questions 3 and 4. So, let us proceed. Based on the pH diagram for R134A tables, the enthalpies values were determined. The enthalpies were found by using pressure values of PT1 and PT2. The pressure values were based on the evaporator and compressor of a refrigeration system, respectively. Hence, we will list out the enthalpy values for PT1, which is 0.675 megapascal, which is the evaporator pressure. And for PT2 is 1.092 megapascal, which is for the compressor pressure. From the R134A table, we can get the enthalpies for enthalpy 1, 2, 3, and 4, which is for 1 is 415 kilojoule per kilogram, and for enthalpies 2, 445 kilojoule per kilogram. And H3 and H4 will be the same, which is 254 kilojoule per kilogram. Hence, based on the values, it is possible to calculate the evaporator cooling, or known as refrigeration effect. Refrigerating effect RE equals to H1 minus H4, which will result in 161 kilojoule per kg. From referring to the table R134A, we can get the mass density, which is 45 kg per meter cubic. For question 4, the obtained value coefficient of refrigerant performance between experiment and theoretical is 24.98 and 29.10 respectively. So it can be concluded that the experiment value is much lower than the theoretical result. So what is the reason? The theoretical value is one estimate based on the existing theory that allows for detailed prediction. The experimental value with an error is a result obtained from collected data that will enable one to get a numerical value of the quantity of interest. When an experiment is confronted with a theory, it is determined whether it is valid within the bounds set by the experimental error and the uncertainty of the theoretical prediction. So that is why. Moving on to the next question.
Hi, my name is Muhammad AISAMUDDIN HANIM bin YUSOFF, metric number MA19250. So, I will continue to talk about discussion number 5, which is the difference between vapor compression and absorption cycle. So, in the vapor compression, the compression of the refrigerant is done by a compressor, which it can be reciprocating, rotating, and centrifugal type. So, for the vapor absorption refrigeration system, the refrigerant compression is done by absorbing the refrigerant by the absorption. As the refrigeration is absorbed, it gets converted from the vapor state to the liquid form, which is it will reducing its volume. So next, we talk about the quantities of power. So in the vapor compression cycle, it requires a large quantity of power for its operation, and it increases as the size of the refrigeration system increase. And for the vapor absorption refrigeration system, the pump requires a minimal amount of the power, and it remains most the same even for higher refrigeration capacities. Next, we talk about the energy. The energy is for the vapor absorption. The system is much more than that required by the vapor compression system. In the vapor absorption system is mainly powered by waste or excess heat in plant, which is the excess steam from the boiler can be used, or more moisture can be generated and used with the available hot water. So, for the compressor in a vapor compression refrigeration system, it will powered by electrical, which is no other energy source can be used in this system. So next, discussion number 6, which is if the refrigerant temperature that's come out of the compressor is enhanced, what happened to the coefficient of performance, or we can call it as COP of the refrigeration system. So, in the actual refrigeration unit, the vapor is in superheated state, isn't it? This superheating is achieved using heat exchanger, in which the liquid refrigerants come out of the condenser, which is subcooled, and the refrigerant is in the evaporator is superheated. So it means the superheating of the refrigeration in the evaporator will increase too in the refrigeration effect. Alright, as you can see in my slide here, the left hand side graph T against to the S. If you can see, the 1 goes to the 2 and go to the 3 and go to the 4 and it backs to the 1. This is the basic cycle where there is no superheat, the refrigerating effect achieved in here. So now the compressor work will also increase as the work done with it without superheating is given, isn't it? So the work input when the refrigeration is superheated, which is, if you can see my right hand side, H2 goes to the H1, which is greater than H2 go to H1. Right. So this is mean the work input to the compressor is the function of the temperature of a refrigerant in the refrigerant is superheated. The work of the compressor will also be increased. Now, if you refer to the formulas that I have given in my slide, the coefficient of performance is the ratio of the amount of heat removed at the lower temperature to work put into the system, isn't it? All right. To producing the fluid is substance that so easily convert from a gas to a liquid and back to the across of a wide temperature and pressure range. For the conclusion, we conduct the detail of studies and analysis the air conditioning working in a principle, and we see and visualize the difference based on the obtained theoretical and experimental result. We also learn how of they use a pH diagram to get enthalpies in the refrigerant system, so that the process on how the air conditioning system work can be studied in detail throughout this experiment. Lastly, for the reference, we refer to the refrigeration formula in 2012 in the textbook of the engineering toolbox retrieved in 2001 to 2021 from that website that I have mentioned in the slide. And we also refer the difference between vapor compression and vapor absorption system retrieved in 2021. Also refer from that website. Last, we refer the coefficient of performance to get the performance, right? In February 16, 2021. And in this reference, we get we get the how to use the coefficient, how to do the pH diagram. Also, we know the current force of the system, which is in refrigerant, air conditioning. All right. So it retrieved in 2021, and from the website that I have mentioned below. So that's all from me and all my friends. Thank you to watching this video.